Hey everyone, this is part 2 of the rose curves notes, and in the last video we did the first 2 problems where we had where n was an even number, and we had an an even number of petals, double that. And now I'm just looking back at that other video and I forgot to put in one of the petals, so that's my apologies on that one. If you go back and look at this other one, I just didn't finish it off. I was getting ahead of myself. I think I was thinking of a different problem and I didn't finish it off. So if you were to finish that off, you would have that fourth petal up here like so. Okay, one thing I also want to note is, remember that the length of your petal is that A value. So all of your petals here, this distance in this particular problem is going to be 6, right? All of these petals have a length of 6. Okay, so I apologize on that last one. I think I got caught up because the time was about to run out, but there should be 4 petals on that one. Okay, if you look at the next problem, r equals 5 sine of 3 theta. If you go back to your calculator and we can change those numbers, so we've got 5 sine of 3 theta. If you graph it, you'll see what it's supposed to look like. And we can go ahead and go to the table and get those values. So we will start at theta is 0. And we'll go ahead and plug those values in. So we've got 0, and then we have 3.5, and then we've got 5, and then we're back to 3.5, and then we're back at 0. Okay, that was for pi over 2, we ended up back at 0. I'm sorry, at pi over 3 we ended up back at 0. Then at 5 pi over 12 we're at negative 3.5, so 1, 2, 3.5 we're here. And then at pi over 2 we're down here at negative 5. At the next one we're going to be at negative 3.5. So at 7 pi over 12, we're at negative 3.5. And then we're back at 0. And then we're going around this way. So at 3 pi 4, let's see. We know that we're going to be symmetrical here. So I know that this one has to be at 3.5. This one is going to be at 5, and this is going to be back at 3.5. Okay, so you can get it off of the calculator. And the one thing about using the calculator is just making sure that you go step by step and know which one of these values is which. But remember, if you look at the graph, you get an idea of what the shape is supposed to look like, and then you can plot your points accordingly. Once you have a few points, you know it has to have symmetry. You know it has to be symmetrical because it's sine. It's going to be symmetrical about the line theta equals pi over 2. So you can pretty much get these other points based off of these 3 points you have here. Okay, so if we were to go ahead and graph that, we end up with a graph that looks like that. Okay, that's 5 sine of 3 theta. Again, n is odd, so I have that many number of petals, so I have 3 petals here, and the distance here, the length of my petal is 5. That's my A value. Okay, the last example, we've got r equals 5 cosine theta, or cosine 3 theta. If you graph that, you'll see what it looks like. Again, this has symmetry about the polar axis. Okay, so once we get kind of half of the points, we can fill in that other part. So if we go to second graph to get the table, I'm going to go back to 0 here. Oops, 0. So these are all of the values from 0 to pi over 2. That's another thing that might be helpful to you. If you start with 0 at the top of your screen, the last entry that will be in this table is pi over 2. So this screen is showing all of your first quadrant entries, so to speak. Okay, so we'll start at 0. We're out here at 5. At the next one, we're at 3.5. At the next one, again, remember that that is 0, right? 5 to the negative 5 times 10 to the negative 13th. That's the same as 0. And again, I'm not sure why it does that. Okay, then at the next value, which is pi over 4, we're going to be at negative 3.5. So I got to flip over the pole. 3.5. And then I'm flipping over the pole again. That puts me at, let's see, where am I? Oh, that will be back at 0. And that puts me down here. And I think I'm 1 off here. Let's see. So I'm at 5. And then I was at 3.5. And then I was at 0. Oh, I missed one. I'm at negative 3.5. Then I'm at, there I am, negative 5. There we go. Negative 3.5, and I'm back at 0. Okay, so far we've got this. Oops. We've got this so far. Remember, we're going to be symmetrical about the polar axis, so I know that my graph needs to be filled in here. And if you notice that the pedal is at its maximum at 4 pi over 3, so I know that at 2 pi over 3 over here, it's going to be the same. And so I know that these are going to be 3.5 and 3.5. And so then I bring my graph through and I end up with the rest of my graph there. Okay, so I know that sometimes it's tricky to kind of follow where you are on the table, but if you kind of just remember your rules of symmetry, cosine has polar axis symmetry, sine has pi over 2 symmetry, or theta equals pi over 2 symmetry. As soon as you get some of the points, then you know where those other points are going to be in order for it to be symmetrical. Okay, so hopefully that helps. You can follow that method. Use your calculator when you're doing these graphs. You do not need to write a table on your paper because you're just copying it off of the calculator, so I don't need to see the work of the table. You can just go right to making the graph. If it helps you to translate what's in the calculator into a table on paper and change these values in here to radian measure and then write the table that way. So if it helps you to do this, theta and r, and doing 0, and then pi over 12, and then pi over 6, and then pi over 4, pi over 3, 5 pi over 12, and pi over 2. Like, if it helps you to do that, and you can write the table vertically or horizontally, and then fill in these values, 5, 3.5, 0, negative 3.5, negative 5, negative 3.5, and 0. If it helps you to do it that way because the decimals are throwing you off, then do that. Okay, like I said, as long as if you graph, and typically if you graph from 0 to pi over 2, that'll get you a good portion of the graph. You may have to go all the way out to pi depending on the graph. But remember, you can also look at the graph on your calculator. Once you have the equation, and press the graph button and you'll see what it's supposed to look like. Use that as part of your guide as well. Okay, so hopefully all those different things with the table and the calculator, the graph and the calculator, all that stuff will help you to graph these. I think you guys should be okay. I will see you next class, and we will talk about lemniscates next time. Okay, have a great day, everybody. Take care. Bye-bye.